Hello and welcome to the latest in the Disruptor series run by the BCO NextGen. My name is Luke Kelly, a project executive at British Land, and I also sit on the BCO NextGen committee for London and the South East. Bit of context for today. So further to the ambitious and legally binding targets to achieve net zero in the UK by 2050, set down in the Paris Agreement, we've seen a marked increase in organisations like my own over the last year seeking to take a lead in detailing commitments to become net zero by 2030. It's increasingly becoming a must-have for clients and customers alike. Our industry contributes around 39% of global emissions. The presentation today and discussion thereafter looks to focus on the opportunity our industry has in contributing to addressing the climate crisis, and I sincerely hope that there are at least a few snippets you can take away into your day-to-day projects. We've got a great panel lined up for you today, all of which will present a short presentation before we go into a panel discussion with the time we have remaining. Firstly, we'll hear about the challenge and opportunities from Juliette Morgan, Head of Sustainable Development at British Land, and Melanie Edis, Climate Change Partner at Environmental Resources. We'll then jump into some practical solutions in addressing the net zero target. Andrew Wall, founder and director at Walther System Architects, will take us through the use of CLT. Neil Thomas, MBE, founder and director of Atelier One, will take us through some innovative structural engineering solutions. And Philip Kite, director at Rambo, will take us through the latest guidance and opportunities with regards to M&E. We'll then finish on with Steve Smith, environmental executive director at Multiplex, to understand more on supply chain and data recording. Without waffling any further, I'll hand over the reins to my esteemed colleague Juliette Morgan to kick off the presentation. Thank you.
Thanks, Luke. So Luke started off by lying, saying that everyone would have a presentation, and I decided that because everyone else would give you a presentation, I wouldn't. So I thought I'd give you a little insight into my life working in sustainable development at British Land. We wrote our net zero strategy and got it adopted by the board this time last year. And the headlines of that are that we would reduce embodied carbon, so the carbon it takes to build a building, by 50% between 2020 and 2030, and we'll reduce operational carbon, so what it takes to run things, by 75%. That sounds like loads. Roughly 50% of that will come from decarbonisation of the grid. So those are our major environmental targets. And just to put some colour on that before I sound like a Newtonian physicist, roughly a new build tower last year would have had about 1,000 kilograms of carbon per metre squared of embodied carbon. And so our 2030 target is to get that down to 500 kilograms of carbon and offset the remainder. So that's what we mean by a net zero building. And many of you will be shocked to know that there isn't necessarily an industry standard that's uniform across all the different metrics around what net zero means. As part of our net zero strategy, we were the first to launch a transition vehicle whereby whenever we complete a building in development, we calculate the total embodied carbon of that building when we complete the construction. And we pay that tonnage of carbon at a price of £60 a tonne to ourselves. £20 of that £60 goes to offset, which is what I've been lucky enough to work with Melanie on. And as of yesterday, we're very pleased to announce that we've just carbon neutralised 100 Liverpool Street, which completed last year. So we spend £20 on offset using nature-based solutions, and the other £40 goes on upgrading the existing portfolio of British Land's properties to reach our 75% operational reduction target. So one of the things that's become really real to us is how you embed this in the organisation. And Luke said I'd mentioned some challenges. So we have ExCo objectives, and they cascade all the way through the business. Everybody has a sustainability objective. We have a CSR committee, a sustainability committee, a sustainability team, and a staff network in sustainability, just in case we didn't have enough. So what that means is that over the last year, it's become business as usual. It's not 15 people in the business that do sustainability, it's the whole business does sustainability, supported by those 15. I work in development, and we are tracking about 650 kilograms of carbon per metre squared across our portfolio at the moment. We're trying to get to that 500 in 2030. One of the things I've learned in the last year is that refurbishments of buildings make it much easier to hit that target. So I just mentioned 100 Liverpool Street. We completed that 394 kilograms, which is ahead of that 500. So our near-term development pipeline is all refurbishments. So 100 Liverpool Street, 1 Triton Square up at Regent's Place, and Norton Folgate. If If you look across the market, not just at our buildings, but in various buildings that have completed in the last year, I'm thinking of things like 80 Charlotte Street, those embodied carbon metrics have been above 800 kilograms of carbon, and that's true for us in new builds as well. So the little upshot that I want to give you from that is that the market needs to prefer refurbs, and historically the agent community and the occupier community hasn't felt that way. The key drivers of carbon are driven by concrete, glass and steel, and so we need alternative materials in order to hit that 2030 target of getting the embodied carbon down. Despite Andrew being here and him being a very good friend of mine, I am going to make the case that timber is not a panacea. That if you don't deal with the embodied carbon in the concrete you use and the steel and glass, then timber cannot fix all ills. That said, it's great for sequestering carbon, and it's very clear across the industry that we need new planning policy, new attitudes to insurance, new attitudes to fire risk in order to be able to use timber. In this country, we're one of the only countries in the world that isn't adopting the use of mass laminated timber at scale for new buildings. So my plea to you and everyone in my business is to use GGBS, replacement concrete, recycled steel, look at the opportunities to use timber and circular economy, particularly think about glass. I think there's a huge conversation to be had around the role of lighter buildings and not over-engineering things. Changing our business model so buildings don't have to be up for 60 and 100 years, maybe they could be up for 15 and 25. And what we need most at the moment are materials engineers and a better attitude to risk. So after we've done all that is when we get to residual carbon, and that's when the lovely Melanie kicks in. That was my rant minus a PowerPoint presentation. And with that, I will give back to Luke.
Thanks, Julia. Over to you, Melanie. Thank you.
Hi, thank you. I've got some slides to share, so let me just share my screen. Are you seeing the slides now?
Yep.
Okay, yes, so yeah, very nice to be here, and thank you very much for the invitation. And as Juliet mentioned, we've been working together over the last few months to explore the world of offsets and how to neutralize a building and work towards the net zero goal. And so I'm here really as the one to terrify everyone with science and how to make transparent claims about carbon neutrality or net zero and offsetting, and just to explain some of what's behind that and how it works, and really some of the things to think about in starting that journey towards net zero. So just a quick lesson to kick off with in terms of greenhouse gas emissions, and I don't know how much of the audience is already involved in reporting greenhouse gas emissions, but if you are, you'll be familiar with the terms scope 1, 2 and 3, which are typically the boundaries of how greenhouse gases are referred to. And traditionally, the reporting is focused on scope 1, which is fuel you burn, the petrol in your car, the emissions which are coming directly out of your activities. In the case of a building, it might be a gas-fired boiler, would be directly generating scope 1 emissions. And scope 2, which is what we call indirect energy. So that is really the electricity that you buy from a third-party provider, so that the power station is emitting the emissions on your behalf. And that would be reported as a scope 2. And so if you go back probably 20 years nearly, companies have been reporting their scope 1 and scope 2 emissions. And more recently, there is much more understanding, influence, stakeholder pressure about reporting beyond those direct emissions into what we call reporting the value chain. And that's where we get into the scope 3, which moves back through the materials, the construction activities, your concrete, wood, where that comes from. So the embodied carbon that comes to you in materials, or the activities of using a building, transporting goods and products, investments, are all reported as scope 3. And there are 15 categories of scope 3 that we don't have time to go into now, which are shown here. But once you embark on that whole value chain reporting, then it's important to look at the full upstream and downstream value chain of the influence of what you do. So when you see carbon neutrality or net zero, it's important to understand what it is that has been neutralized, whether it's just the direct emissions of operations or whether actually it extends into the full value chain. There's lots of language around this, and this webinar is about net zero, and so with that in mind, net zero is about the trajectory to eliminate greenhouse gas emissions from the footprint. It's about the whole decarbonisation of activities, including scope 1, scope 2, and the relevant value chain emissions. There are other words that you'll see, like zero carbon, like you might buy zero carbon energy if it comes from a renewable source. You see carbon neutral very commonly, which might be a product, or you might be able to take a carbon neutral taxi journey or receive a carbon neutral washing machine because the company has offset all of the emissions associated with making that. You might see carbon negative or carbon positive, where there's a trend now for double offsetting, or putting a big margin of offset so that you are more than offsetting your activities. And you're also seeing now companies moving towards the science-based target initiatives, and we'll talk about that a little bit because it's really integral with the net zero concept of decarbonisation and moving towards what that means. And a little bit of the science when we talk about net zero, that term stems from the IPCC, which is the Intergovernmental Panel on Climate Change, which is part of the UN process. And they issued a special report on the global journey towards holding the temperature rise at 1.5 degrees and set the pathways of how that might be achieved. And these trajectories are some of the modeled pathways that have come out of that IPCC survey, and they have firmly stated that we need to be on this bottom path, the 1.5 degree pathway, in order to safely manage the climate emergency. And what that means for you or for any entity or country that is making this net zero commitment. And one of the important things to bear in mind is that this is a moving feast. And these 4 graphs are what they call pathways. And it depends on how quickly we move. So if we move quickly and decarbonize quickly, there's actually not much to do by the time we get to 2050 and beyond. We will have decarbonized and we won't have to invest in vast amounts of carbon removal, for example. If we don't move quickly and we end up in the P4 scenario, then we're going to need huge investment in carbon removals in order to compensate for the inevitable ongoing emissions that mankind is putting into the atmosphere. So they put forward these pathways in order to encourage governments and businesses to stick as close as they can to this early mover pathway, because that's the way to minimize that ongoing problem and the need for this massive investment in removals. And this is directly linked into the Science-Based Targets Initiative, and there's increasing numbers of companies now which are signing up to the science-based targets, and that's about you setting a company setting its own targets, and that's a commitment to be in line with that trajectory. And what that means is that if the world doesn't move fast enough, then we've all got to do more. So it will, if we get to 2030 and nobody has done anything, then everybody's going to have a steeper curve that they'll have to move down. So what everybody does on a day-to-day basis is going to be challenged by how the global initiatives move towards decarbonisation. And we'll see at the COP meeting in Glasgow at the end of this year, what the international governments sign up to. And the UK is one of the few that has already signed up to a net zero commitment. There are other countries that are now doing that. But it'll take a lot more countries than already have to actually make this 2050 net zero commitment. And that journey takes us down here, and it accepts that there will be a need to build up removals to balance. And then it's got here what it calls the optional compensation. And this is where we get into the whole raft of offset investment, which enables the sort of voluntary compensation for these activities as we get this journey towards the complete decarbonisation of what we do. Now, how you get there is that offsets are many and varied. There was a comment, just as a question about whether offsets can be local or whether they come from far afield. At the moment, any offset that you buy is going to come from far afield. The nature of the way that the international process has worked over the last 10, 15 years has been that emission reduction projects tend to be in developing countries or in North America, and that's politics behind that around the way that the Kyoto Protocol was established and followed through. So there are certain schemes, some of which are listed here, Gold Standard, the VCS, the Climate Action Reserve, which are established. They have registries. You can buy an offset from one of them and it is cancelled and transparent in a registry. The difficulty with just planting a tree, for example, is the controls that sit behind that to make sure that there isn't double counting, to make sure that it's permanent. And you'll see these categories on the right, that to be a valid offset, it really needs to be real, measurable, permanent, additional, verified and unique, so that you and only you have got hold of that offset, and you and only you have retired it or cancelled it in a registry. Now, there are many types to choose from. Juliet just mentioned that British Land has used removals in forestry land use type offsets. You will also find many what we call avoidance type projects as well, which might be improved waste disposal, generating biogas, taking agricultural waste to turn it into biogas. It might be towards renewable power. So there's still a lot of projects available which are good in that journey towards decarbonisation. But it's important to remember they don't remove carbon dioxide from the atmosphere. They simply prevent an emission from happening that might otherwise have happened if that project didn't exist. So it's really a choice, and that choice is still open as to the type of offset that is used. And there's definitely a tendency towards a preference for removals, which actually will be taking the carbon dioxide out of the atmosphere. The other thing to think about is the scope 2, which is the electricity. And ideally, your power would come directly from a renewable provider. In the absence of that, it's possible to buy a tradable certificate of renewable energy. In Europe, they're called renewable obligations, or REGOs. In the UK, in the US, they're called RECs. There are also IRECs, which are international renewable energy certificates, and those can provide a backup, so that if you don't have direct access to renewable energy, you can make sure that you have backed up the electricity you buy with a renewable source from elsewhere. And it acts a bit like a carbon offset, but it's a slightly different instrument. And the other thing to think about, and when you're buying an offset, is
we may just need to, if we can just contribute to the agenda, if that's okay.
Sorry.
If you can just, I think you've got a couple of slides left. If you can just try and finish off, and then we can move.
Yep, I've got 2 left, I think.
Okay, thank you.
Yep, and I think this was the last one with any message on it,
Thanks.
which is just to say that some projects come with extra bells and whistles. You can with extra societal or biodiversity or other benefit. And then there's the journey of how to get there, which I think the rest of the webinar will be addressing, is how you get that journey. And then there are lots of places to go. Just a few, you will, if you're interested in this topic, there are plenty of places to go to find out more information. So thank you.
Really, really useful. Thank you so much.
Yep.
Andrew, over to you.
Hi, thanks for that, Melanie. So this should do that, and then do that. Boom, can you see me? All dressed for Christmas? Yeah?
Thank you.
Thanks, Luke. Hi, so I'm Andrew Waugh from Waugh Thistleton Architects. This is us here, and we are an architecture practice based in Shoreditch in London. And as you can see, we are crazy about timber. We've been building and researching and drawing and thinking and hugging timber trees for a long time now as a practice. And that work has been residential buildings. Built our first one in 2003. In 2008, we built a 9-story tower in Shoreditch, which was, I think, probably like the first tall timber building in the world, and which was a fabulous experience. And we've continued to kind of look at sort of how we can best build in timber, how we can kind of, you know, progress that architecturally, you know, to work for different types of buildings, different contexts. And in that time, we've kind of begun to understand, I think when we first started it, you know, the idea that, and it was all about actually kind of like, just to sort of like to reiterate, that was from our perspective, all about sustainability. So it's all about reducing the embodied carbon of the construction industry and the, you know, the sort of understanding the implications of what we were drawing as architects. So in terms of operational carbon, you know, we all understand that operational carbon is something that has been vastly reduced in the last decades, that my own view is that, you know, that keeping on sort of reducing that operational carbon often ends up with increasingly complex systems, increasingly complex kind of ways of trying to deal with buildings, and sort of putting a lot more stuff into those buildings. And, you know, often doesn't allow us to just open the windows or put a jacket on in the winter, or, you know, or take your jacket off in the summer, which is probably a far better idea. So operational carbon is something that we've, you know, obviously we've understood, or we reduce wherever possible, but decarbonisation of the grid, etc., is kind of, I think, an important kind of, it will probably be the kind of most effective tool to do that. But the actual kind of like carbon footprint of the buildings that we build is something that we've been looking at, as I was saying, for quite a long time. And so these timber buildings that we built, I want to talk to you about one today, because I'd be honest with you, what we've just really started to get our teeth into is the metrics of this, is how to actually calculate this, how to communicate about carbon in our buildings, in the building process. I think we kind of, you know, as a practice, we've just thought, I think for a long time, well, we build in timber. You know, that's got to be the most kind of green and sustainable kind of practice for construction that there is. But now increasingly understand that we need to think about the life cycle analysis of those materials, making comparisons with other construction methods, so we can really actually begin to highlight that. So this is an office building that we're doing for the office group in Shoreditch in East London. It's a 4,500 square meters gross area, a 6-story building. And I wanted to take you through some of the calculations we've been doing for that building. So the building has a large concrete basement, concrete piles, but above the ground floor slab is entirely made of timber. So the core is made from softwood, cross-laminated timber, as are the floor slabs and the party wall here at the back. And then the columns and the beams are made from laminated veneer lumber, which is sort of like plywood made from sort of jumbo bits of veneer, and then laid in parallel, which make an extremely strong kind of section, about as strong as the same size would be in steel. So this building completely timber from the ground floor slab up. Now, this building at the moment in the structure is about 265 kilos of carbon dioxide emitted per meter squared of the structure. If we built that in concrete, it would have been nearly double, about 450 kilos. And if we count the sequestered carbon, so that's the carbon that's actually stored within the timber itself. So if you imagine timber being that kind of magical carbon store that we're all looking for as it hoovers up carbon dioxide from the atmosphere and spreads oxygen amongst the, around the world, it retains the carbon in the body of the tree. It's about 70% of timber itself is pure carbon. So if we think about the carbon that's stored within the timber, then that reduces that figure down by about 210 kilos to, so we get about 55 kilos of carbon dioxide emitted for the entire structure per meter squared. And so looking at that structure, looking how it's made up in a pie chart, I love a pie chart. So 265 kilos, as I was saying before, so this is all the concrete in the gray, and then the hardwood beams and columns there, about 3%, the CLT, about 24% of all the carbon without counting sequestration. And then if we count the sequestration, we can take that much kind of the burden of the concrete out. So as I was saying before, down to about 72 kilos of carbon. And then if we were able to include the sequestration, about 17 kilos of carbon dioxide per meter squared. And that's done by using this timber structure. So really simple, you can see here, kind of these are all the steel connections buried in the timber in order to fire protect the steel. We do that by using the timber. So you can see really simple connections, then a timber curtain walling system. On the outside of the building, we have, it's completely clear glazed in order to make the most of kind of natural daylight. And then we have on the outside of the building, some solar shading using a thermally modified timber. So that's one that's kind of basically been boiled in sugar beet juice and will mean that the timber will last about 50 years plus. So you can see there on the outside of the building and some very short, itchy people kind of wandering around there. So the carbon targets, the kind of metrics that we work into as a practice are those set by LETI, the London Energy Transformation Initiative, which I think probably is the kind of the most forward-thinking of industry bodies in terms of carbon reduction. And these are the targets that LETI began to kind of set through conversation with the industry. So we're at the moment 2020 best practice, about 600 kilos of carbon dioxide. This is for a typical multi-story new office build. Target for 2030, so 9 years to nearly half the current targets, to 350. And then if we include sequestration, about 250 kilos is what LETI have established, a kind of cross-consultant target for those, established target for those. And so we, when we start to bring in the mechanical, the finishes, the facade into that, we have as a building 477 kilos of carbon dioxide. That's from A1 through to A5, so the entire construction of the building. If we built it in concrete, again, about 50% of an increase there. And if we built it, if we include the sequestration, a reduction of nearly half of what it is to about 256 kilos for the whole thing.
That's great, Andrew. Thank you so much. Really insightful.
And that's just wanted to say, Luke, that in terms of the actual kind of, where the construction material comes from, this is the equivalent number of tree seeds that we would need to grow the trees that built the building. Thank you.
That's great. That's really insightful and really pioneering stuff. Neil, over to you.
Thank you very much. Can you see my screen now?
Yes, we can. You may need to, if you go view and full screen, it may show it in a bit of a clearer fashion.
Okay, got me. Andrew, thank you very much. I'm glad you did the metrics because I'm not, but they were very useful as a lead into what I want to say. I think everybody understands the difference between this question of embodied carbon and sequestration, which is something that we are pursuing as an idea. And I have here in front of you a series of headlines from magazines from about 18 months ago, when we were commissioned by Juliet Morgan, our first speaker, actually, to look at a sustainable alternative to concrete floors in buildings, in office buildings. And these headlines we took up at the time: architects should give up concrete, say experts at Architecture of Emergency Climate Summit. The point being, I think Juliet said about using low carbon producing concretes, but actually the production of the concrete, the cement that goes into making the concrete, produces a huge amount of carbon dioxide. And we'd said, well, fine, let's just set that aside and look at other materials. Let's fill our cities with taller wooden buildings. I think, again, Andrew, thank you very much indeed. You've led into that very nicely. I think you've got a perfect explanation why wooden buildings are better in your cities. And I have one other thing to add to the end of that there, and that is on the right: bamboo transcends the tropics for carbon negative construction. Sorry, just one moment. We all know, and we're all familiar with wood, timber, CLT that Andrew's mentioned. We worked with an architect, Field & Clegg, a number of years ago on a building for the Woodland Trust in the Midlands of England. Oddly, when we started working with them, they were advised that they should build a concrete building because it would be cheaper than building any other. And timber was, they are the Woodland Trust, after all. It's a bizarre idea. But we worked on the development with them, and the point I wanted to make, because I am a structural engineer, from a structural engineering point of view, we're interested in efficiency, form, and trying to make things lighter, so that, in fact, materially, the elements have less embodied carbon, specifically because you've used less. This building, when we went through the whole process, and we did of comparing a concrete frame with a CLT and a timber beam frame, came out to be exactly the same price as the concrete frame and its associated parts. And the reason I bring that up is because I hear very often people talking about the fact that they immediately add a premium to the cost of timber buildings. And I think it's something carefully designed and properly designed that I am showing you an example where that's not true. I mentioned bamboo. I have been traveling to Bali, where I teach about the engineering of bamboo and design of bamboo. Bamboo is an amazing material, lives and grows all through the tropics across the world. Huge amount of bamboo, 1,600 different species throughout the world. It's very, very light. It weighs 1/10 of that of steel, 600 kilograms a cubic meter as opposed to 6,000. It's incredibly strong. You can see that, I don't need to explain. And it grows rapidly. This is a diagram of a piece of bamboo from one day to the next, 24 hours later, and it's grown, you can see, 5 centimeters, 2 inches. A bamboo culm can grow from its basic shape, from the initial base of the culm to full height, as much as 20 to 30 meters and 20 centimeters and 25, 30 centimeters of diameter in a matter of 4 months. And going back to the point that Andrew's making about sequestration, there's an enormous sequestration of carbon in the process of it growing. So it's an interesting material, but this is the kind of thing that gets built in the tropics in Bali, the kind of thing everybody knows and loves about bamboo, natural form, very, very beautiful. But how does that work in terms of the kind of stuff we're talking about, building in a modern Western construction industry? Well, in the relatively recent past, and it's in its kind of infancy, but it's happening, they are taking bamboo and converting it to those engineered sections that we all know and love in timber, CLT, laminated timber, etc., etc. This is an incredible product known as radially laminated bamboo. I mentioned that we were commissioned by Juliet and British Land. They asked us to take an existing building that they got in for planning down at Canada Water Canary Wharf called the A2, and see if we could convert it with engineered natural materials. And we were going to now consider either timber or bamboo. The floor construction is, as you see there, concrete deck over a steel frame with the spacing of frames about 9 meters, and then a floor void above, which has in it a plenum. So the kind of servicing strategy was that you have a plenum above the concrete deck beneath the finished floor. They said we had to meet all the requirements necessary for the office floor, the office buildings they have. So structural systems criteria, structural requirements, vibration, which is a very important thing in particularly with timber because of its elasticity and lightweight, deflection requirements, acoustic requirements, fire requirements. But then we also had to maintain all the building systems exactly as they were. They did not want us to kind of go and change them, come up with bespoke systems. That's the environmental strategy, glazing solutions, etc., raised floor systems. So jumping to the solution, which took a year, but I'm going to get there anyway. We drew on nature and folded plates. Nature is a great place to look for ideas in structural engineering, I promise. If you've ever got some time, go out and do it. Just see these fans, these palms, they are folded surfaces. It gives them extra stiffness. So we took the idea and applied it to the floor system you could see below there. And so this is the comparison of the two, the original solution, their concrete floor, with the raised void for the plenum, and our proposal for this folded plate timber and or bamboo floor. And it's very important to understand that the depth of the structure there, the 3 dimensions, 120, 410, 120, make up a very steep, stiff, deep section using shape stiffness. Using shapes to, sorry, excuse me. I can't talk to you. Sorry, my daughter just walked in the door, apologies. Folded plate floor, apologies first. Folded plate floor in either timber or bamboo. Now, look at this. This is the diagram of mechanical properties. In the center there, you have a typical timber GL24. And look, just take parallel to the grain compression, 21 newtons, doesn't matter the numbers, 21. Baobab, which is a densified timber, which we use in larger, taller buildings, has potentially compressive resistance of 59, so 2.5 times that of typical timber. Now look to the right, the Renewtec Veralam, which is the radially laminated bamboo I showed you a minute ago, is 93. It's almost 5 times that of typical of a kind of standard timber. So amazing things happen, right? So now we've got the stiffness through the shape thing. And now what we're doing here is comparing the charring of a typical floor. So you see a deck on the left here, floor spanning onto beams, and the beams span that hierarchical system, and out the folded plate system we talk about. It could be switched either. Both could be bamboo, both could be CLT.
Sorry, Neil, I'm going to give you a 2-minute countdown.
Okay, no, I need one minute. Okay. The standard floor system with its hierarchical system, because it burns through and reduces the stiffness of a horizontal plate, over a 2-hour fire gives you a reduction in stiffness of 73%. The folded plate did this amazing thing. Because of the nature of the geometric stiffness of it, its reduction in stiffness in the same fire condition was by 39% only, which means you can use a lot less material. So there on the at the top here, this is the kind of diagram of all the systems requirements. On the right-hand side, a fixed system of floor means everything meets all the requirements that the concrete and steel one would do. And that's the model that we built to show to Juliet and her colleagues to show that we could make this thing work. Thank you very much.
Thank you ever so much for that, Neil. Really useful and innovative. Philip, over to you on the MEP side.
Yeah.
I'm just conscious of time, so I think if we can try and stick to the 5 minutes, that would be useful, and then we'll go to Steve.
Very good. Can you see that?
Yes, I can. Yeah.
Okay.
May need to press slideshow, but
yeah,
it should be fine.
There we go. Right. So shooting on. So our new metric on the MEP side is how much energy we use, and we do that in kilowatt hours per square meter per year. And we have a target to meet to get to zero, anywhere near zero carbon, which is 90 kilowatt hours. So this graph is quite interesting. It shows our kind of a typical existing office building stock. So we're currently around about 200 kilowatt hours a square meter. That's fairly standard, and we need to get to below 100. So even our best buildings at the moment with EPCs of A and B don't really make it. So we've got some serious work to do, and we need to change fairly radically how we go about servicing buildings. So we have Neighbours UK that started last year. So we've imported this over from Australia. So over the last 12 years, their buildings have gradually improved, and they've just about hit the 90 kilowatt hours per square meter target. So that took them 12 years. We need to do this tomorrow. So are we capable of making such a fundamental change to our buildings to be able to deliver this? So we do have some problems. So here's just another graphic that shows the over design that we get in buildings in terms of capacity compared to what buildings actually use. And I think this is kind of a key pointer to our kind of poor design and our approach to design that needs to change. We need to do something fairly fundamental. So I just want to show how we go about this. So this is a graph of the London climate, number of hours per year against different temperatures. So the trouble with the building services side of things and developers is that they give us a design brief that says you must hit this target in winter, -4, and you must hit this target in summer. And these become how we start designs. But buildings don't actually operate for any significant length of time at these extremes. If we want to do things better, we've got to look at what happens for most of the year. So our new design criteria should be 10 degrees C. And then what we have to do is actually look at how buildings perform over the year. So overlaid on the same graph of number of hours at different temperatures, there's a heating load and a cooling load for a typical office building. And you can quite clearly see that for 70% of the year, the building kind of ticks over. It's well below its design capacity. It's down at 15%. So if you've designed your building to meet very high cooling loads, you're just not going to get operational efficiency and effectiveness at such high loads. You really need to take a different approach to how you design the buildings, and you've got to design from the inside out, not from the kind of outside in, at least in terms of the graph. So intelligent design is what's required, and what we need to think about is hybrid solutions. So we've got a lot of tools in our MEP toolbox, lots of different ways of doing it. And you have to approach every job with the right mix and the right allocation of these different solutions. And you need far more variety for any particular building, so it operates most effectively for any particular temperature and any amount of demand placed on that building. So this is quite an exciting project we're working on with British Land, 2 Finsbury Avenue. So it's just got planning permission. So it's a fairly enormous building. But our mantra is, how can we design a building that's capable of housing 7,000 people? How can that building operate efficiently for 30 people on a bank holiday weekend? Now, if you can do that, I think you can hit the 90 kilowatt hour per square meter target. And that's the challenge. It's a bit of a rethink. So this is how we've approached it. So our heating system, so we've actually got 2 heating systems. It kind of lends itself. We've got two towers, one to each tower, and we got some heat pumps. So we actually find that the building heats itself largely. We just collect the heat in heat pumps, and we put it back into a heating system and pump it around and round, and that works really well. The cooling system, so we've kind of got 2 cooling systems. We've got the heat pumps, which are the same heat pumps that do the heating. They do heating and cooling. So the cooling is actually the collector of all the heat that's produced by the occupants, by the lighting. And we just put that through a heat pump, and we can heat the other parts of the building. It's really efficient, really effective. So we can run the whole of this building on these quite small heat pumps at the top of the towers for 7 months of the year. In the summer, clearly it gets hot, so we need more cooling, but we have a number of kind of modular chiller arrangements that we can turn on So we can just bring on the amount of cooling we need very efficiently and very effectively. Ventilation, clearly that's a big issue at the moment. So we've got a variety of ventilation systems. On the right-hand side, the eastern tower, we've got floor-by-floor ventilation plants. We've got 2 small air handling units on the floor, so clearly we can get good control from that. The challenge is what do you do with big air handling units serving large floor plates? How can you do that effectively? So typically, one of those air handling plant rooms has got 3 big air handling units, each serve a separate riser. But it would just a simple duct connection between the air handling units. We can get 1 air handling unit to serve all 3 risers, and we can put some modular fans in it, say 6 fans. So we've instantly got a 5% downturn on that ventilation plant. So we're just making big strides forward. And the other thing to do is how do you actually control ventilation on a big building floor plate? So what we're doing is we're dividing the floor plate up into zones around about 150 square meters. The ventilation goes through the floor. So you can occupy any one of those zones and control the ventilation to those zones just on occupancy sensors and CO2 sensors, and just bring fresh air to that one zone on one floor without having to supply air to any other part of the building. So that's how we're designing this, and we are getting very close to the 90 kilowatt hours per square meter target. So not only operational energy and operational carbon, we're also looking very hard at embodied carbon. So one of the interesting things about diversified plants, so rather than a big 9 megawatt chiller plant with a 450 diameter steel pipe coming out of it, we're going for a distributed plant. The pipe work's a lot smaller, so it saves 43 tons of steel pipe work, which is a significant saving in terms of CO2. And then, well, let's look at different materials as well. So this is polyethylene. So we can save 85% of the carbon that we would have had in steel and copper pipes by going to different materials. Refurbishment, perhaps the biggest opportunity. So this is another project that we're looking at. So a fairly standard existing energy consumption, 250 kilowatt hours a square meter.
Sorry, Philip, I think we're going to have to cut you short.
This is the last slide.
Oh, okay.
So we're getting down to 130 with a relatively simple and straightforward refurbishment. So it can be done. Thank you.
Poor timing from me there, Philip, sorry. I feel like the Grim Reaper cutting everyone short, so apologies for that. We're trying to cover a lot today, so thank you. Over to you, Stephen, to finish off.
Can you see my slides?
I can see your pretty face.
I think he's frozen.
I think he's gone off, actually. So I think that gives us a nice segue to some questions to kick it off then. So please, everyone who's attending the event, do raise questions in the Q&A box to kick it off. Against the backdrop of perceived customer demand, I mean, the data there, Philip, obviously shows that it's possible. But against a backdrop of perceived customer demand, do you think that achieving what we need to achieve out of energy performance, specifically looking at the MEP systems, is achievable?
It is achievable. I think the challenge is bringing the occupiers and the tenants along with us, because you can design the best system in the world, but if it's not used properly, it's not going to work. So I think everyone's got a part to play, and that's the big challenge in this.
And Juliet, from a client perspective, and specifically from ourselves in British Land, what do you see as the key barriers to that in terms of our customers? I can give you my view. I think it's a challenge in just educating.
Juliet, you're on mute, Juliet.
Yeah, I think she's struggling to unmute it. I think the challenge is making sure that that tick box exercise when customers take spaces isn't a barrier to enhancing specifications needlessly. Andrew, you talked a lot about sequestration within your presentation. within a lot of data I've seen, it's included in some assessments, it's excluded in other assessments. Is there a qualified metric to assess embodied carbon? And if not, what kind of obstacles do you see there?
There are several kind of different life cycle assessments that are available, and each one of the major kind of engineered timber manufacturers will have their own kind of EPDs and life cycle analysis that you can look at in order to help you work through those metrics. But it is something that I think the timber industry needs to work a lot harder on, because a lot of those calculations are quite old now, maybe 10, 15 years old, some of those LCAs. And actually what we're finding is that as the concrete and steel industries realize that they need to kind of like hone their metrics down a bit and make themselves look a little bit more attractive, I think that there have been other methodologies applied to how people work out LCAs. So I think that it's something the timber industry needs to look at carefully. I think that sequestration, to my mind, if the equivalent is, burying carbon in the North Sea or whatever it might be, then to my mind, the more that we use timber, the more trees that we will grow, and that's the kind of, I know it might sound a bit kind of like, Milton Friedman or something, but it is kind of like, the economics of it are such that when we build with timber, we store carbon in that building. And then, because all the timber that we use in the UK is in our buildings is certified, every tree that's cut down, five are planted in its place.
Great, thank you. Do you think there's enough benchmark data? Maybe the question for Neil and Philip, to be fair. Do you think there's enough, and Melanie to a degree, do you think there's enough benchmark data to look at a package by package budget against the targets of 2030 to create targeted benchmarks of CO2 per metre squared for, say, facade, structure, and other elemental parts of a building? Or do you think there's some way to go?
There's something I want to add, sorry, Luke, to what Andrew said a moment ago.
Okay.
It's what's very important is demountability, because sequestration is only any good if you keep it sequestered.
Yeah, absolutely right.
And so at the end of the life, and I've heard talk of shorter life buildings, which we definitely will support the idea of, and the idea that they're modular, demountable, and can be taken away. I mean, we're currently engineering the British Pavilion Expo. The whole thing is demountable and will be returned and put up in different places so that it has a kind of ongoing life. That's very important, because otherwise, if you take timber and just bin it afterwards, everything goes back into the atmosphere again. So, and in terms of packages, I think it's happening. It's beginning to happen, but it will become more comprehensive as time goes on. Right now, no, I don't think there is, and I think it's fascinating listening to Melanie, who I've never heard speak before, but how her not understanding, but her clarity about how these things are defined. And I find it the most difficult thing is getting a consensus on what we're all agreeing is what. Yeah. And but that's bound to happen. It's because it's all come up kind of very big, quick rush, and everybody's an expert in these things right now, and they've come to the game a few minutes ago. And so listening to a professional like Melanie is a pleasure, actually. And I think I will be back in touch with her after this conversation.
There's been a number of questions in respect of the use of timber and obstacles in respect to fire brigade and insurers. I know from first-hand experience that insurers are a bit of a challenge in this respect, and it's very much seen as an innovative material that hasn't been used for centuries. So I think there's definitely an upskilling of the insurance market, which definitely is in motion, to be fair, but needs to come up to speed with some of the design solutions that is being put forward. Juliet.
I feel like they're technically enabled now that I can actually turn the mute button on. I would say that we managed to get insurance for Osman Road, which is a building that we were lucky enough to work with Andrew on. And the only reason we got insurance was because of the scale of British land. And the attitude of the insurance industry at the moment is that you get total catastrophic failure of the building And really what we need, and someone's mentioned it in the chat, is how do you bring along the planners, the fire brigade and the insurance industry? And the only way we're going to do that is through lobbying. It's through almost like systemic conversations like this one, like that we've got someone here who's doing offset, we've got someone here who's doing engineering, we've got someone here who's doing design for deconstruction. And until we have systems level conversations, we are having conversations in silos, and we need the literally law change. And I think the COP26 and the opportunity this year for organisations like the BCO, like BUP, UK GBC, all party parliamentary group, until we get the environmentalists to understand that the regulation within the building industry, from a planning perspective, fire, regulatory and insurance, we are being prevented in a design perspective from being able to meet that carbon target. So systems theory, systems level conversations, and massive amounts of lobbying. And if anyone's got time to do massive amounts of lobbying, then I really want to talk to him, because I think increasingly it can't be on individual developers to try and lobby. This now needs to be an industry voice, and that industry voice to literally marry the carbon agenda and the planning agenda.
Yeah.
I think we've got time for maybe 2 more questions. Juliet, what do you see? I think we've separately had a discussion on this, but what do you see as the key obstacles to achieving BL's target of 2030, net zero target of 2030? But moreover, obviously the industry is part of that as well.
I think for me, it's material innovation and the willingness by the planners, the customers, the insurers, the financiers, that the collective attitude to risk needs to change. When we change the collective attitude to risk, and Felix completely said it, we are now in the world of designing hybrid buildings. So looking to what we've always done historically is not going to give us the answers. So I think the issue is around attitude to risk and willingness to explore new opportunities.
Great. You during our discussion as well, you mentioned diversity as well. I think that's a really interesting point. Do you want to expand upon that? I think it'd be really useful. That's what I was kind of leading your answer.
Candle. So somewhat controversially, I pointed out that a lot of buildings historically, maybe not so much now, but are commissioned, procured, designed, financed, approved predominantly by men of a certain age with a certain educational background. And I think until we have diversity of input into those buildings, and what by that I mean women, people of colour, people of different background, people of different educational background, people of different physical ability, we cannot design places for all of society if we don't have all of society designing those places. And I think there is a critical point now for design teams to look more diverse in terms of their composition, to design relevant places. And I think that genuinely is the key to sustainability, because sustainability has to be about the use of those places and the financing of those places and their ability to sit on this planet in an inert way. And we are so consumed with the only customer being the finance, and that isn't true anymore. So there is I believe a really big role for balanced conversations.
Thank you, Juliet. Steve, I see you. Thanks, good to have you back. From a supply chain and data perspective, what do you see as the biggest barriers to the current setup in achieving what we need to achieve?
Yeah, sure. Sorry about that. I was just kicked out. My computer froze. So it was great timing as well, wasn't it? Look, I'm fortunate as a contractor to inherit all of these wonderful designs and engineered solutions, and it's really our task to pick them up and then try and collaboratively work with the supply chain, who is already extremely complex, and both laterally and vertically, and to bring them along for the journey takes a lot of effort and rigor. So for us, the first step is trying to get a handle of your data. We've had science-based targets in place since 2017, and that has literally just acted as a launch pad for us to start exploring where innovation actually exists. So my advice to any organization is get to grips with both your organizational data for carbon, and then get to grips with your whole life carbon data at your asset level, and then start having conversation with your peers to get broader alignment on the monitoring of that data, and then start to bring the supply chain along for the journey with you. Because I think as you start to speak to them, talking about diversity of thought and opinion, there are brilliant supply chain members out there, and we need to be listening to them more often than not. So that's my 1 minute. So sorry about that.
No, that's really, really useful. And thank you very much, Steve. And thank you very much to all the panelists today. I think we could have had 1 hour listening to all of you. We've tried to fit a lot into the 1 hour slot. It's useful. I read something interesting yesterday that I thought summarized it well and hopefully resonates with some of the participants here, is that we're not necessarily in control of the macro side of things and at state level in terms of what driving that, but ultimately it falls to us as individuals, employees, companies and citizens to drive that change. So if hopefully you've got a couple of snippets from today's session that you can take away and use in your day-to-day projects. But thank you very much for your time. And again, thank you very much for the panelists, really appreciate it. And have a good day. Thank you.